All right, let's get into it. Today, we're going to pull back the curtain on these little magic boxes that pretty much run our entire world. We are going to demystify once and for all what is actually going on inside your computer.
I mean, seriously, just take a second to think about the phone or the laptop that's right in front of you. How does it turn your clicks and your taps and your swipes into this? It seems impossibly complex, right? But the core idea behind it all is actually surprisingly simple.
Okay, so let's just dive right in. The absolute easiest way to wrap your head around a computer is to stop thinking of it as some complex machine and start thinking of it like a really, really high-tech kitchen. Seriously, everything it does just follows one basic recipe.
To get started, let's look at the official definition. A computer takes in raw data, that's our input. It processes that data using a set of instructions, which is just a program, and then it gives us a result, and we call that output. That right there is the foundation for everything. And this slide, boom, it lays out the whole process perfectly. Every single computer, I don't care how big or how small, follows this fundamental four-step recipe: input, processing, output, and storage. So let's break each one down.
So, let's start at the very beginning with step one, input. Now, in our kitchen analogy, this is the part where we go and gather up all the ingredients for whatever digital meal we're about to make.
So what are these ingredients exactly? Well, input is just the raw information we feed the machine. Every letter you type into a search bar, every number you punch into a calculator app, every photo you upload, yep, that's all just raw data.
And how do we get those ingredients into the computer? We use input devices. And you know what's wild? You use these things every single day. Your keyboard, your mouse, that microphone, the touchscreen you might even be using right now, they're all just different tools for adding ingredients to our digital kitchen.
Okay, so all the ingredients are in, it's time for the chef to finally get to work. This is the processing stage. This is where the magic happens, and that raw data gets transformed into something actually useful.
And our master chef is the CPU, the Central Processing Unit. This is the brain of the whole operation. It reads the recipe, which is just the software, and it carries out every single instruction, one by one. And get this, modern CPUs have multiple cores, which is literally like having several chefs in the kitchen all at once, all working on different parts of the meal at the same time.
Of course, every great chef needs a kitchen to work in. For a computer, that kitchen is the motherboard. It's the main circuit board that connects all of our key components together. The CPU, the memory, the storage, they all plug right into the motherboard, which lets them all talk to each other and work together. It's the central hub that makes the whole cooking process possible.
So, our chef has used the ingredients and cooked up something amazing. What happens now? Well, this brings us to the final two steps: presenting the finished meal and maybe saving the leftovers for later. This is output and storage.
Output is simply the result of all that processing. It's the finished meal, served up and ready for you to enjoy. The very text and images you're seeing on your screen right this second, that's the computer's output. And the computer can serve this meal in a whole bunch of different ways. Most of the time, it's the visuals on your monitor, but it could also be a physical paper document from a printer, or the sound coming out of your speakers, or even a presentation on a big projector. Now, we need to talk about something really crucial: how a computer remembers things. This slide explains it perfectly. Think of RAM as your kitchen countertop. It's super fast memory that holds everything you're currently working on. But, and this is the key part, when you turn the power off, poof, the countertop is wiped clean. It's gone. Storage, on the other hand, like a hard drive, is your pantry or your fridge. It's where you put things away to use later. It's a bit slower to get to, but it keeps your files safe and sound, even when the power is off.
Okay, so we've seen the ingredients: the chef, the kitchen, and the final meal. Let's zoom out for a second and see how this whole system comes together to become a computer that actually works.
When you really boil it all down, every single complete computer system on the planet, from your smartwatch to a massive data center, is made of just three essential parts. That's it, just three.
And here they are. You've got the hardware, that's the physical kitchen and all its appliances. You have the software, that's the recipe it's following. And most importantly, you have the user. That's you, the cook. And these three aren't just a list, they're a team. The hardware is useless without software to tell it what to do, and both of them are just sitting there waiting until you, the user, decides what meal you want to cook. So here's the crucial takeaway. Hardware is the stuff you can physically touch, it's the potential. Software is the set of instructions that gives that hardware intelligence, but it is always the user who gives the entire system its purpose.
And what's really cool is that this simple kitchen model scales up in some incredible ways. So for example, the difference between a giant supercomputer and a mainframe isn't the basic recipe, it's just how they cook. A supercomputer is like a Michelin star kitchen, focusing all of its incredible power on making one super complex dish as fast as humanly possible. A mainframe, on the other hand, is like a massive hotel kitchen designed to cook thousands of different meals all at the same time. So that core recipe, input, process, output, storage, that's the timeless foundation of all computing. Which brings us to a final and pretty fascinating question. This basic model has been the same for decades. So looking ahead, what new kind of ingredient, maybe our voice, our gestures, or maybe even our thoughts through brain-computer interfaces? What do you think will be the next big thing to fundamentally change this recipe for generations to come?